So welcome to this session, this new session on these 40 hours of microbiology. And this session is about the new coronavirus pandemic. And the idea is just to discuss and the lessons from Portugal and from Brazil. So we have made an effort to highlight the positive roles of microorganisms in our lives and in the economy, but obviously it was not possible to ignore this virus pandemic. And the session will start with a presentation, will be followed by a panel discussion. I will introduce the panel afterwards. So the presentation will be given by Dr. João Paulo Gomes. He is affiliated to the National Institute of Health, Dr. Ricardo Jorge in Lisbon, and he has been coordinating a very important work on the diversity of the new coronavirus, SARS-CoV-2 in Portugal. So, please, João Paulo.
Okay, first of all, I would like to thank the opportunity to give this talk to the international community. And I would also like to say good morning, good afternoon, and good evening, depending on the global location you are listening to this. So I was asked to present the example of how Portugal is using the whole genome sequencing data from the new coronavirus to monitor the COVID-19 infections in Portugal. And that's why the title of this presentation is Genomic Diversity of the New Coronavirus SARS-CoV-2 that causes COVID-19 in Portugal. So I would say the first question is why? Why studying the genetic diversity of SARS-CoV-2? Well, several reasons for that. I would point out the first one, and probably this is shared by most study groups worldwide. We use whole genome sequencing of the new coronavirus to monitor transmission chains and to identify novel introductions in Portugal. Regarding transmission chain, the concept is like this. So the whole genome sequence of the coronavirus is like its identity card. So if I become infected with a specific coronavirus, and if I pass the infection to my relatives or to people I'm working with, then it's supposed that the sequence of all these coronavirus are similar. So that's exactly what this figure is all about. So if this one is infected and if it passes the transmission to this lady over here, and then she goes to the family and passes the family to all the relatives and so on, and during at her job, at the job work, also it passes the infection to other people, and then we have a transmission chain. And how do we identify the transmission chain? If we sequence all these viruses, we will get similar genetic sequences. So the goal is to use the whole genome sequencing data to inform the health authorities that an outbreak, a transmission chain, is occurring, for instance, in a school, in a household, whatever, and try to block it. And if we block a transmission chain, we will avoid multiple infection, multiple transmission events. Regarding the identification of novel introductions in Portugal, I'm saying Portugal, but it's the same strategy every country is using to identify the introductions during the early epidemics. The concept is basically the same. We identify the virus that are circulating in our country, and then we compare the genomic sequence with public databases that are available worldwide. And if we find matching sequences, then we ask the public health authorities to provide us with information regarding the metadata, regarding travel history, local of putative infection, contacts, date of infection, date on symptoms, and so on. And that's the way we will try to identify how many introductions we had during the early epidemics in Portugal. The second goal of studying genetic diversity of SARS-CoV-2 is to measure the impact of the containment efforts on transmission chain outcomes. We all are aware that probably every country closed schools, restaurants, airports as strong measures to contain the infections and to contain the new introductions. However, we must find out if these measures were taken in due time. So we will use the data generated regarding the genetic diversity of SARS-CoV-2 to find out if the transmission in the community occurred after, during, or previous the most of the occurrence of the novel introductions, and above all, if these measures of closing schools, closing restaurants, and closing airports were effective to stop the transmission. The third point I would highlight is the determination of the genetic variability of antigens and targets of antiviral drugs with impact on the vaccines and therapeutics. And I'm saying that because the sequence of the new coronavirus has several proteins, and at least one of them is pointed out to be crucial for the development of the vaccine and for the development of antiviral drugs. It's designated as the spike protein. So it is believed that mutations occurring in the spike protein is here represented in yellow, is a protein highly abundant that covers the entire surface of the SARS-CoV-2 and is responsible for the virus attachment and entry into our cells, and is also a powerful antigen. So we develop an immune system against this protein. So the rationale is that if we find mutations in this spike protein, then we may have problems with the vaccine effectiveness. And also we may have problems in the development of antiviral drugs, because the conformation of the protein may change and the protein may no longer recognize the antiviral drugs. And finally, we use the whole genome sequencing data to determine possible association between mutations or groups of mutations that are here designated as genetic profiles with clinical outcomes. I mean, disease severity. So it's possible that while most whole genome sequence of the circulating virals are associated with mild infections, and we know this is the case all over the world, we may find out that some genetic profiles, some mutations may be associated with fever or with low disease severity cases, but some mutations on some groups of mutations may putatively be associated with more severely disease groups, like patients needing ventilation and so on. So this is pure speculation, and there are a lot of groups worldwide trying to find out this association between mutations and disease severity. So the second question is, how do we study the genetic diversity of SARS-CoV-2? Well, in Portugal, we started by creating a consortium enrolling more than 60 hospitals and labs that are spread throughout the country. And the role of these labs were to diagnose COVID-19 and pick up the positive samples and send the positive samples to the National Reference Lab in Lisbon, designated as the National Institute of Health. And then basically using classical wet lab procedures, we pick up the genetic material of SARS-CoV-2, and we use several equipments, heavy ones and light ones. This one, by the way, fits in the palm of the hand. It's very, very, very short, to perform the next generation sequencing. And then all the work is performed by using computers. Okay, basically what we get is a huge amount of small pieces of information, short sequences. And if you pay attention, all these short pieces somehow overlap with each other. So what the computer does is it puts everything together, it joins the overlapping regions and create a massive contig that we name as the whole genome sequence of the new coronavirus. And it's with this sequence that we work here with. And we pick up this sequence and we put it in the publicly available databases. And most important one is designated as GZ. And finally, we have created a website to the scientific community. All results are available in this website. The access is completely free, so anyone can enter the web page. It's regularly updated with the data that we obtain in a real-time fashion. And also very importantly, it's user-friendly. So anyone, regardless the degree of knowledge in genomics, can try to understand information that it's contained on it. The web page is this one, and I'll make a short guided tour right now. So the web page works exactly like this, and it opens like you're seeing now. It's a bilingual. We can change it to English, okay? And for the ones that do not want to navigate throughout the web page, you can just go to the latest situation report. It's a PDF. We have several of them disposed in chronological order. And this PDF basically tells you the story of what is most important according to the new data that we have obtained. But if you want to have a little bit more work and to navigate a little bit more, you have the goals of the study here, just clicking in. And some notes, tips for enhanced data navigation for the ones that have expertise in the field, and several reports with all the highlights disposed in chronological orders, the teams involved, the methods. This is very important because we believe that this procedure may serve as an example for other countries to do the same. So we have all the rules available for the wet lab procedures, and also for the bioinformatic parts. And finally, obviously, the acknowledgements and the context. Okay. So I'll show you a couple of examples how to navigate this and how to extract information from this. So far, we have almost 2,000 sequences of the new coronavirus that infected people in Portugal. So I can tell you that Portugal is the third country with more sequences available worldwide regarding the population that we have, 10 million. So basically this is a phylogenetic tree. The colors, each dot represents a sequence of the virus, and the colors represent the location where the virus was isolated. So basically, the colors represent small villages, cities, towns, whatever, in Portuguese mainland and in Portuguese highlands. And basically, the concept of interpreting a phylogenetic tree is that the virus at the end of a branch, this is a branch, all of them at the end of one branch are more closely associated in terms of genetic similarity than if we compare these ones here with the others at the end of a different branch, okay? So if you want, for example, to identify a transmission chain, an outbreak, for example, an outbreak in a school, we have to choose.
Oh, sorry, may I interrupt just for a second as moderator? Just you need to share the PDF or the websites. We are not seeing the web page of InsaFlu, okay? You have to, we are only seeing the presentation. So please share the browser.
Okay, I'll try to find out how can I do it.
Sorry for the interruption.
Okay, sure. So you're not seeing?
We are only seeing the last slide from where you have the web connection, the web link for InsaFlu, InsaPET, COVID-19.
I'm sorry for that. Let's try.
Ah, great.
Oh, I'm sorry for that, okay?
So if you don't mind coming back a little,
No problem. Will we have time to do that? Like 5 minutes more?
I hope so. I hope so. I'll try to take it from the moderation.
Okay, I'm so sorry for this, okay? I thought I was sharing the web page as well. Okay, so this is how the web page looks like. This is the downloads, the PDF I was talking about for the ones that do not want to navigate. It's just clicking in. The PDF is open and with the latest news, and then you close it, okay? And I'm sorry, I have to put it in English again. Yeah, it's in English. The goals of the study, you just have to click here and click again, okay, to hide it. Here, just have to click for the ones that have a huge expertise in the field and want to navigate deeply in the website. Okay, just click in and click out. All the reports disposed in a chronological order, all them in PDF for simplicity purposes. The teams that are involved, the methods I talked to you about, the wet lab methods, and the bioinformatic procedures for any country that wants to do exactly the same procedure as Portugal is doing, and acknowledgements and so on and so on. So again, as I was telling you, we have analyzed almost 2,000 sequences for the new coronavirus. As I was telling you, Portuguese is ranked third in the number of coronavirus that are sequenced and that are released in the public databases, mainly in GZ, which is the major public database available for the whole worldwide scientific community. And this is what I was talking about, the phylogenetic tree. So the colors, the dots represent the sequence of the virus with the metadata in this black box, okay? And the different colors represent different locations where the virus were isolated from. Villages, towns, cities, whatever, in Portugal mainland and also in the Portuguese highlands. And the viruses are placed here according to the genetic similarity and to the number of mutations. Take a look at the scale here. This is the number of mutations that each virus has, each virus reveals when compared with the first coronavirus that was sequenced in December by the Chinese groups, okay? All over the world, the procedure is the same, regardless the lab who is doing that. The phylogenetic tree is basically the same. The scale is always the number of mutations compared to the first virus that the Chinese people sequenced. Okay, so what we can see here is that at the end of a branch, the virus within this branch are more similar among each other than if we compare all these viruses with the ones at the end of a different branch. So this is the principle to analyze a phylogenetic tree. So, as I was telling you before, if you want to identify a transmission chain, a mini outbreak, for instance, occurring in a school, you have to try to find out the virus at the end of one of these branches and try to find out if they are similar. And I will give you one example. Here, I'll click here and I will forget the rest of the tree and I will just zoom in everything that is at the end of this branch. Okay. So this is a zoom in of everything and we have now much more information. And as you can see, we have a lot of small branches, okay? Let's take a look, let's walk through this branch. First this branch and then this branch, and let's take a look at the green dots. Here we have 3 green dots and also 3 green dots here. The green dots mean that this virus was isolated in neighboring regions or eventually the same region. And when they are disposed vertically, it means that these 3 share 9 mutations when compared with the Chinese one. And these 3 share only 10 mutations when compared with Chinese one. However, when we compare these 3 with these 3, only 1 mutation is revealed. So if we take a look at this, we have a virus isolated from someone infected in Trancoso. Here, Guarda, here, Guarda, Sluric-Bebeira, Trancoso, and so on. And I can tell you that all these regions are neighboring regions. And these 6 viruses have almost matching sequences. So I can tell you for sure that we have identified the transmission chain. And so next step is to provide this information to the health authorities so they can know exactly that this specific variant of the virus is spreading in that specific location, and they should establish and identify the contacts to stop this kind of transmission chains. The last information I would like to give you within the site is, let's go back. Again, take a look at the colors. And if you take a look at this color, violet, I can tell you that the violet corresponds to all virus sequenced in the Atlantic pearls. This is the nickname, the touristic nickname of the island Madeira. Okay, beautiful Portuguese island. And all the virus sequence in Madeira have the violet color. And if you take a look at the whole tree that has about 2,000 viruses, you see that the violet is spread throughout the whole tree. This means that the coronavirus in Madeira represent a huge, a massive genomic diversity. And as you can imagine, this makes a lot of sense. This means that Madeira have a huge amount of introductions through the flights from other airports to Madeira. So this makes a lot of sense, and probably each of these violet points yielded small transmission chains within the highlands of Madeira. So that's all for the website. I'll go out. I hope I'm doing the right thing. Okay, yeah. You're seeing the screen now?
Fine, fine.
Okay, let's proceed. So finally, I'll give you a brief example of one of the most important results we have obtained so far, because at this stage, we are analyzing the data that we can extract from this massive genomic tree. So what can we extract so far from this study? I can tell you that the first conclusion is that the early COVID-19 epidemics in Portugal was characterized by the massive spread of a SARS-CoV-2 genetic variant. This genetic variant contains this specific mutation DE39Y in the spike protein. What does this mean? I told you about the spike protein, the yellow one here that covers the full surface of the virus and is responsible for the attachment and entry into the host cell. And 839 is the position, the amino acid position in the spike protein where these amino acids was replaced by this amino acid, okay? A glutamate was replaced by a tyrosine. And according to literature, the mutation from the glutamate to the tyrosine at this specific amino acid position in the spike protein, in this protein, is believed to impact the virus entry. Take a look at the spike protein here, and take a look at the entry process. It's the spike protein that is involved in the connection with the host receptor. And it's believed that this amino acid position, as well as others, is crucial for this entry process. So we speculate that maybe there's a conformational change in the spike protein that may impact the entry rate in the transmission. And curiously, this variant, DE39Y variant, was introduced in an industrial area in the north of Portugal after the staff attendance to an international trade fair in Milan, Italy, Lombardy, okay, in mid-late February 2020. And what is funny about this is that it means that it circulated undetected in Portugal before the first COVID-19 confirmed cases, because you probably do not know that, but the first reported cases were 2 cases on March the 2nd. So this means that for at least 10 days, we had a massive transmission chain that we were not able to detect. And this is the scenario we observed. On March 7, take a look at the red portions. Okay, the red is the proportion of the infections caused by this genetic variant. On March 7, the scenario was like this. On March 18 was like this. And on April the 30, we had this massive spread of the variant throughout north and central of Portugal. And so we estimate that between March 14 and April 9th, because we used mathematical modeling and to speculate and to perform these estimations, and this corresponds to the exponential phase of the epidemics in Portugal. This variant likely caused about 4,000 COVID-19 cases in Portugal, meaning that 1 in each 4 cases during this period of COVID-19 in Portugal was caused by this specific genetic variant that the national health authorities weren't able to control until they applied the measures I talked to you about: closing schools, closing restaurants, closing the airports. And it resulted in the largest transmission chain ever reported worldwide. Here, I use different colors for you to better visualize the genetic variants. All these yellow dots represent the coronavirus sequences that correspond to that specific variant in the spike protein. And all of them, as you can see, come from the same branch, this branch that divides in 2 and so on. So all of them came from the same common ancestor, because we speculate that everything came from Italy, from that trade fair, from a single introduction in our country. And here is the spread by the end of April. And finally, what's ongoing now? We are now finalizing the data by analyzing this phylogenetic tree that we have, and we ask for a huge amount of data from the public health authorities regarding the travel history, the date of contacts, number of contacts, the date of symptoms, and so on, to identify all introductions that occurred in Portugal during the early epidemics, meaning during the month of March. And then when we have this information, we will also search the international databases to search for virus for which we have a matching genetic sequence with ours. And then we will check the travel history of our patients, and we will try to figure out which of these errors are true and how many introductions we have, and present the data in a chronological order to learn not only with these epidemics, but also to apply new measures in the future epidemics. Thanks a lot for your attention. I'm sorry, really sorry for what happened during this the screen share. And thanks, a special thanks to all consortium members that provided us with all the samples. Thank you.
Thank you, João Paulo. Superb work. So now we are going to enter the discussion at once. And I'm going to introduce the panel members, the other panel members, and the moderator of the discussion. So one of the panel members is Pedro Simas, Professor Pedro Simas, my colleague at the University of Lisbon, Universidade de Lisboa. He's a virologist, so he is affiliated to the Faculty of Medicine and also to the Institute of Molecular Medicine, João Lobantunes. Well, he is currently a very well-known person throughout Portugal on account of his constant and important and of course very well-received presence in Portuguese television news, explaining the science behind the virus and guiding everyone during this new coronavirus pandemic. So the other member of the panel, because it's important, the experience of Brazil. Brazil is a country with which Portugal has strong ties, but unfortunately the situation, the health situation in both countries is not similar. Fernando Spilki is president of the Brazilian Society of Virology. He's affiliated with the Universidade Feevale, Porto Alegre, in Brazil. Thank you Thank you for accepting our invitation, Fernando. And to moderate the session, we have Miguel Viveiros. Miguel Viveiros is Vice President of the Portuguese Society of Microbiology. He is Deputy Director of the Institute of Hygiene and Tropical Medicine of Universidade Nova de Lisboa in Lisbon. His institution is also involved in fighting the pandemic, and considering the mission of the institution, he has knowledge about the situation in Africa, in particular in countries that speak Portuguese, like we all in this panel. So, Miguel, I will leave now the discussion with you.
Thank you, Professor Isabel, and President of the Portuguese Society of Microbiology. Thank you all for the presence. Congratulations to fans and to the other societies involved in this long journey celebrating the Microorganism Day. And unfortunately, the entire world is under severe constraint due to a microorganism. So it's a new era of challenges, and we have seen here a good example of how science can help medicine, science, and in particular molecular biology, molecular epidemiology, can be of extreme importance, not only to diagnose, but to follow and to monitor and trace chains of transmission of coronaviruses. So congratulations on Paulo. We have been leading this project in this consortium, and it's not only a consortium involving health authorities, but it's important to acknowledge the involvement of the academia and of all the academic laboratories. And here in Portugal, we had this fortune in the early days of the pandemic. Our government was, let's say, clever enough to bring together public sector, private sector, academia, to bring enough strength for early diagnosis of coronavirus through molecular biology. And this made a huge difference, not only on early detection, but also in contact tracing. So part of the results that João Paulo have presented, they have been possible only because this consortium was created among all these IT entities, and it was a free exchange of results and samples. So my first question goes to Fernando. Fernando Spilki. Let's see the perspective in Brazil nowadays and how things are going in terms of the impact of molecular biology and the connection between public health, health control, coronavirus control in Brazil, laboratory network, and the struggle to control the dissemination of the viruses, and of course connecting with the molecular biology and the early detection of the viruses. Fernando, the floor is yours.
Well, first of all, I'd like to thank Dr. Isabel and to you, Miguel, for the invitation, and to fans to be part of this session. It is a pleasure, and of course it's an honor to be part of it. And I would like also to congratulate João Paulo. Your work is amazing. I'm in charge of a huge Brazilian network for the sequencing of the virus, and we have a lot of sequences made by many institutions, but now we are starting with a huge network of 10 institutions in Brazil and more than 100 researchers that will perform something very similar to what you have shown us, and I think that many of the hints, and especially about the website, the way that you propose this to show to the people, I think that I will copy some of your ideas, because that was very good. We are studying this work right now because the money is coming now from the government for it. You know that bureaucracy is another thing that we have heard from our Portuguese relatives, but we are now starting this work. But a lot of efforts have been done until the beginning of the pandemics in Brazil, and many of our groups are working together with the state governments and the municipalities to make both the diagnosis and the genomic characterization of the virus. But from the part of the federal government, we have these mixed positions about the pandemics. As you know, the Minister of Science in Brazil is giving us a lot of support in terms of financial support, and also you know that Brazilian universities are likely in Portugal. We are doing a lot of efforts for the diagnosis. Actually, in some states of Brazil, we have much more samples analyzed in universities than in the public laboratories nowadays. So this happened also in Brazil. But of course, as you know, Brazil is a continent, and in some moments, the Brazilian government did not give the right instructions for the people, and given the huge social inequality and a lot of other problems that we have right now, we are now passing through this apocalypse in terms of COVID compared to many other countries. But from the last month, the situation is now flattening a little, and we are seeing not so many new cases every day as we saw in the middle of May or until the middle of July. And but we are a little concerned about the possibility of a second wave. And that's one of the things that I would like to ask to João Paulo and to you after. How are you seeing the situation in Portugal? Do you believe that you're gonna have a new waves of the pandemics, or what can you tell us about that from the diagnosis, the routine diagnosis that we are doing on a daily basis for the future?
Thank you, Fernando. João Paulo, just a short comment, and then let's listen to the expert opinion of Pedro that has been following all this process from the beginning. João Paulo, as a health authority, how do you look at the current situation? Nowadays, we had 700 and something new cases. The 9th worst day in Portugal. Clearly, it seems the beginning of a second wave, or at least a severe increase in new cases.
Yes, I would say that there's no doubt that we are starting to face a new wave, probably a giant wave. But I will like to listen to Pedro, because I believe he has basically the same opinion as I do. I'm not as worried as probably most of the people regarding this new wave, because I truly believe that we are nicely prepared, not for everything, but we learned an important lesson to protect the ones that we must protect, and to give some degree of freedom to the ones that, for the ones we must do that. And I'm talking about the opening the schools and so on. So there's no doubt the second wave will be there. And I believe that Portugal will be prepared to that. At this stage, taking a look at the hospitals and the intensive care units and so on, the situation is not worrying so far. But well, let's have our fingers crossed. And please, Pedro.
Pedro, should we relax? You agree or not?
Well, hello everybody, and thank you, Professor Isabel. Professor is my colleague for a long time, for the opportunity to be here. And thank you, Miguel and João and our colleague in Brazil. I think inevitably we will see an increase in the new infections, a substantial increase. And as Miguel and João have just said, I think we are prepared to have that increase in a controlled fashion. And what that means is that our high-risk groups are protected. In particular, the care home, people in the care homes are quite well prepared. I must remind you that the lethality rate in care homes was about 40%, which is in the lower side of the average for Europe, and so that's an unequivocal demonstration that Portugal did a good job protecting our high-risk groups in the care homes. What I'm worried about now is the people that are outside the care homes, because if you look at the data, people above 70 years of age, up to now, 55% of the lethality came from there. So there are lots of people in a society that are potentially exposed to this new rise of infections. My hesitation of calling it a wave is because my understanding, that's my personal understanding of a wave, is that there is a connotation with something which is not controlled. It's just a wave that comes and is huge and causes devastation. And I don't think that will happen. I agree with Miguel and with João, and why? As Miguel and João were saying, the Portuguese, they call it the Portuguese miracle, which I don't like, but they call it the Portuguese success in the first wave, was due to two things mainly, in my opinion. One is that the size of our wave was very small because we were very prompt at introducing the lockdown, so we didn't linger on that, and so the seeding was very low in the country, and we are benefiting from all these months that we are relaxing the measures. We have benefited from a small seeding of the virus, but as you know, viruses disseminate in an exponential way, and above a certain threshold, things can get completely wild and exponential. So we have to be careful that we are still in this lag phase of seeding, and that worries me a little bit. And the other thing that was crucial for the success of Portugal was the fact that we, as Miguel said, we brought, there was a huge spontaneous initiative from the Portuguese academia and scientists to bring about the capacity of Portugal to test. And test, as you know, is crucial to do the tracing and everything. I mean, as it has been for the last so many years in infectious diseases. So otherwise we are blind. And so now I'm very hopeful that we are about to change the game in Portugal in terms of testing. And I'm working actively on that, which is we have to go from a situation where a strategy where we were testing people that had clinical signs, people that were supposed or are suspected to be infected, and isolating them and doing the contact tracing, for a situation where, and sending them home into isolation and quarantine, to a situation where we want to do surveillance testing, to send people, negative people, back to work, back to school, okay? And we also want to do surveillance testing to absolutely try to guarantee that health workers that work in care homes do not introduce the virus into the care homes. It's not just like looking after running after the damage. Once it's there, then you have to do all the things, and so I think I'm very hopeful also that the Portuguese people have understood that this is not a joke in inverted commas. We are at the beginning, not at the very beginning of the pandemic, as I said before, but now at the beginning, because we already have a degree of herd immunity, but we're still at the beginning. And so I was very pleased with the WHO yesterday that they announced that the world is at the beginning of the pandemic, because there is this, what we are seeing now in this rise of infections, which are still within a value or a range that is still safe epidemiological, because we have about 40 new infections per week per 100,000 people. It is still on the safe side. Look what happened in Israel. There are over 300 new infections per week per 100,000 people, and they had to go back to confinement, to lockdown, which is something that we do not want and you cannot afford in our country. So I'm hopeful that the Portuguese people will understand that. The Portuguese people will look back in the summer and say, well, look, well, we know what we did. We know that we had more movement, and that's why the cases are rising. We have to follow the rules, and we have the physical distancing rules that the Portuguese people have integrated very well. We have the mask, which is in Portugal, for Portuguese culture and structure, is absolutely vital that we wear a mask, and children wear masks in school. And then we have the tests, and we are trying to change the tests and bring back academia. And now, as we speak, there are a number of institutes, about 21 institutes in Portugal, academic, not from the National Health Service, that are going to help again the National Health Service to change this game of the testing and increase the capacity and introduce rapid testing. And I'm sorry if I was too long.
No, thank you. It was a great perspective, and yes, we are at the bridge of a new era for this pandemics, at least in Portugal, and massive testing. It's going to be essential to control, mainly to prevent transmission. Now that we are opening the schools, going back to what we call the new normality, and yes, the instrument to have is testing, it's social distancing and the masks. Unfortunately, other countries, other perspectives have been discussing the use of the mask and how it prevents the transmission. I think nowadays there are enough evidence that this is crucial, but I would like to go back to Fernando, and besides just one question coming from the audience and from the thousands of viewers of this session, we have picked up two questions. This one goes to Brazil. If you have to choose one main reason besides the political reason for why the pandemics, the virus is not under control in Brazil, exactly which one would be? Social aspect, difficulties in the healthcare system to provide healthcare, or everything goes down to the lack of political support for what is considered the control measures implemented by the public health. Fernando,
I think that there is a mix of things that could brought us to the situation. Not only the political stuff, but I think that the social inequality is one of the problems, because it's truly difficult for poor people remain in social distancing. So there are many people living in houses that have no more than one room, and 3 to 4 to 10 people living in these places. So it's impossible to talk about social distancing for people that lives with less than 100 euros per month. So that won't happen, actually. People have to go to the streets to fight for survival. That's the way it goes. Another thing that could have some importance is something that we are studying right now, is that we have this B1.1 lineage in Brazil that was also the major genetic lineage of the virus that was in United States, and we know that this lineage could be more transmissible, and that's one of the things that could be there. And another thing that I think that could have an importance is that that Brazil has many countries inside of it. So we have some states in which you could have a very good healthcare system, or one of the main cities could have very good healthcare and others don't. So people are moving and transmitting the virus from one city in which the situation was controlled, and you have all the ICU beds that we need, and people move from this city to another city that yet did not have the virus, but and then an outbreak explodes, and the city has no chance to fight this. And the other stuff that I think that we have to deal with it is that a part of the population, I would say that something like 30% until now do deny the importance of the pandemic. So it's not only in the federal government, in some people from the federal government. Masks that do not believe about the struggle that we are living through. So it's a complex mix of social and economic related stuff, and maybe some biological background from the virus. And in our network, we are also studying some hypotheses about the genetic variability of the hosts, but from that part I have no results to talk about that until now. So, but I think that social economics and maybe some of the characteristics of the virus could be enrolled in this. And our response was too delayed in some of the states. That's true. And the social distance was also too short in many places, no more than 10 days. So you won't fight the virus this way. That's the way it goes.
Thank you, Fernando. We have 5 minutes to go because the schedule is tight. But one last question comes from our audience directly to João Paulo, and if you still have time, the other members of the panel might comment, is coming from the genetic sequencing and detecting specific mutations. There is any notion, any evidence how specific mutations might influence disease progression versus asymptomatic colonization and the severity of the disease?
Unfortunately, there's no evidence. There's no enough data to support that kind of conclusions. I pointed out that point as one of the major goals of multiple group scientific research groups spread, worldwide spread, because that's a very important point. If we could find a way to have an association between some genetic profiles and disease severity, and then use diagnostic tests that rapidly inform you about the presence of those specific mutations, that would be a priority, because then we will give a priority to those patients, to those infected people. That would be great. But I would like to say that people probably have no idea that it's very, very, very difficult to access metadata regarding clinics, severity, and so on. In Portugal, I would say that it's almost impossible to do that, unless the clinicians inside the hospitals want to do the job and contact you. But the reverse order is not possible. So due to data protection and so on, so it's very, very difficult to perform those kind of studies. I have no idea if in other countries will be more easy to do that, but that's a research line that would be tremendously useful for the progress of the medicine and to control the pandemic.
Thank you, João Paulo. Just one last question to our two moderators, and I'll go back to Professor Isabel to close the session.
May I ask a question myself?
Oh, please do.
Well, to the two virologists,
the hope,
not to close.
a message of hope.
to both virologists, in particular, our colleague from Brazil, about the florestation of Amazonia and other forests, and the coronavirus or other pandemic problems, let's say, because there have been long warnings for the inevitability of a global pandemic at this scale. What do you think about this?
That's one of our major concerns regarding Amazon. Many of our groups are studying new viruses there, and we have found a lot of new flaviviruses, and we have also paramyxous viruses very similar to Nipah circulating in animal hosts there. So the type of destruction of bad use of the forest that's being done right now from the last years, I think that's a threat to the world. To human beings, actually, because there is a recent expansion of minery and of agricultural and animal husbandry in the Amazon, that I think that will pose a threat for the next years. We are wondering that we will have a lot of new viruses being introduced in the next decades from this place, because we have already found these viruses. As you know, Brazil has a lot of virologists.
Yeah.
That's one of the wealth of the country, and we have found a lot of new viruses, not only coronaviruses, but as I said, flaviviruses and paramyxous viruses that are somehow new, but very similar to very dangerous viruses that were found in Malaysia and other parts of the world.
Pedro, do you want to comment or to add?
Just I agree with it in principle, but I'm still hopeful that we can somehow revert things, and it's not that easy to break the species barrier. As you know, that many of these viruses break the species barrier, but are not adapted to humans. So let's hope that that doesn't happen very, very frequently. But we need to respect nature for many reasons, not only due to pandemics. And I would like to see it on that perspective, rather than just because we had a pandemic, now we have to save Amazon. We have to save it because we have to save it for obvious reasons.
Difficult, but not impossible. Okay, so we have to close the session. Thank you very much. The session will be online, so you can watch the session again or for the first time soon. Thank you very much. Thank you, all the speakers.
Thank you.
And
Bye.
the moderator.
Bye-bye.
And FAM's office. Thank you
very much.
Bye. Thank you.
Bye-bye.
Thanks a lot, everyone.